Hello, welcome to our recorded webinar of our Sustainable Sourcing Checklist Generator demonstration. My name is Nat Springer. I'm a postdoc with the Agricultural Sustainability Institute working on our Sustainable Sourcing project. Now for a summary and development of this project to date, check out our other webinars also posted on our Institute's website. But quickly, the main purpose of this project is to help food companies and other food system stakeholders develop frameworks that can define and measure the sustainability of agricultural raw material sourcing. So these frameworks can then be used to develop strategies to improve sustainable sourcing practices across commodities and regions. Now this demo presents a specific process that our team has developed to achieve this purpose. This process can be used by anyone who wishes to create a comprehensive list of sustainability issues and indicators to measure the sustainability of agricultural raw material sourcing for a specific supply chain. So in other words, this process that I'm about to show you takes the general concepts and tools our team has developed to this point and shows how to apply them for a specific commodity sourced from a specific place. Now just to give a bit of this general context, our team has harvested a large data set of over 2,000 existing sustainability indicators taken from a number of existing global initiatives and data sets relevant to the sustainable sourcing of agricultural raw materials. Now, these indicators provide information about different types of issues, including natural issues, human, social, physical, political, and financial issues, and many of these indicators are relevant to multiple categories. So although the multitude of indicators gives decision makers many different ways to measure sustainability, it also makes it very difficult to identify a manageable set of indicators to represent all the issues one cares about in a specific context, since really it's unrealistic and unnecessary to track this entire set of indicators for each case. So at the same time, it would be nice to know that any indicators and issues that are chosen are recognizable and being used by the broader sustainability community, and also ideally by groups working on a similar list of issues, commodities, and regions. So the goal then becomes how to identify the subset of indicators for a given case, drawing from this larger global set of existing and consistent issues and indicators. And that's the checklist generator approach that I'm going to show right now. So the main goal of this demo in showing this checklist generator approach is to also show how a company may derive different sets of indicators to measure different issue lists for a specific commodity, region, and framework. As you can see here, I'll present 4 use cases that identify 4 different issue and indicator sets, all legitimate sets, but different depending on these contexts. So the main takeaway is that different indicator sets will be useful for different cases. And the goal is not to identify a quote-unquote optimal set, but a useful manageable one that is informed by a pool of available indicators and issues that come from a scientifically validated process with consistent organizations providing these resources. So to illustrate the role that sustainability frameworks play in this process, note that under the first 2 use cases shown here, these 2 consider the impacts of sourcing decisions on sustainability issues, while the latter 2 consider the vulnerability of supply chains to the issues. So now I'll go through each of these cases one by one to show how one may derive a useful and manageable indicator set for each case, and at the end of the presentation we'll come back and look at the 4 different lists and we'll see how those sets compare. So in the first case, actually, in each case, the first step is to choose relevant issues that apply to your specific sustainability context from a broader list of issues. So now, as described in previous webinars, our team has harvested this global list right here of 44 sustainability issues taken from the broader sustainability community. So each issue here is integrated from these sources using a controlled vocabulary. And these integrated issues are then comprised of various component issues that cut across all 44 of these. So for example, the issue water includes components such as water availability, water scarcity, water pollution, et cetera, et cetera, et cetera. So this network of issues then provides a pool from which to draw a subset of issues for specific contexts. Again, our team has collected a concurrent list of over 2,000 indicators that provide information about each of these 44 issues. And you can see that this is shown here at the funnel on the bottom right of the screen. So keep an eye on this funnel as we proceed through this demo, and you will notice how this number slowly becomes more manageable as we go through this process. So the first step here, as you can see, is to consider the framework. And our team here at Davis has already divided this list by those generically relevant to the sustainability impacts in sourcing decisions, and those which make global supply chains more vulnerable, and as well as those that are both relevant for both frameworks or neither framework. Our team did this first for the impact framework by asking the following question for each one of those issues. We said, so does raw material sourcing have a significant and direct impact on this issue? So if this was generically true for a given issue, meaning in the context of the entire global food system, we placed that issue in the impact framework. And the picture here on the left shows our UC Davis team. However, this question could really be answered in any number of ways, including through participation with relevant experts and stakeholder groups. So the picture on the right is from a meeting our team had with a group of stakeholders back in December 2012, where we presented this list of 44 integrated issues for comment and validation. So in this way, if this question is posed to a more specific stakeholder audience, this process can be thought of as a negotiation support, or a way of identifying the set of issues that are directly relevant for a given case, however narrowly or broadly defined. So again, at this generic level, the list of impact issues identified by our team is shown here. So you can see on the lower right, this already slightly lowers our available indicators that are linked to the selected 24 impact issues, as those indicators are the only ones that provide information on the 24. So, but ultimately, most companies, users, stakeholders will not be interested in a generic global list, but a very specific list of issues relevant to a specific supply chain, region, or commodity. So here we turn to impact case 1, which narrows the impact question to say, what is the appropriate indicator list for us to make for a comprehensive sustainability claim on the impacts of a specific commodity sourced from a specific place? So in other words, what list should we use for this commodity in this place? So again, just as with the generic question, this question can be answered with any number of participants present, ideally with the stakeholders who can best speak to the relevance of the issues from the various perspectives surrounding the region and commodity. Now for this demo, our team has chosen to look at groundnut sourcing in northern Nigeria. So this was a commodity and region that we chose to look at early on in this project, not only for indicators but also data associated with those indicators, in collaboration with colleagues from Mars Incorporated. So say you're a decision maker and you're concerned specifically with the sustainability impact of your groundnut sourcing decisions in northern Nigeria. So what issues are relevant in this case? As an exercise to demonstrate how this would work, two of our team members, myself and ASI Director Tom Tomich, considered this question for all 24 impact issues, along with the various components of those integrated issues. So ultimately, this process of identifying a subset of relevant issues, again, could be done in collaboration with any number of stakeholders, but just for this demo, it was me and Tom answering these questions. So for the sustainability impacts of groundnut sourcing in northern Nigeria, Tom and I identified 15 of the 24 impact issues as directly and significantly relevant, shown here. So note that these 15 issues still cut across all the different types of issues, and with these 15 issues identified, the number of indicators useful to provide information about them, again, once gets cut down now to just under 1,500 indicators, or already 25% less than the original set. So although this is useful, it's still way too many to be manageable. So the question now is, well, how do we get from a large set like this to a manageable set of indicators that measure these issues that are important for groundnut sourcing in northern Nigeria? So one intuitive strategy would be to simply look through the list of nearly 1,500 indicators and begin choosing them one by one to represent each issue. So that would work, but not only would this be a time-consuming process, but since many of the indicators can provide information on multiple issues, it's also likely that such a technique would result in an indicator set that's larger than necessary. So, for instance, consider a simple case where we have 8 issues and 5 indicators to measure them. There are many overlapping links, and hence not all indicators here are necessary to represent these 8 issues. So one thing, if we just decided to pick, we could choose the first 3 indicators, and that would work. We'd represent all the issues on the right, but you can see that indicators 3 and 4 both link to issue 4. On the contrary, we could choose indicators 2 and 5. And this also happens to provide information on all the issues, but it requires us to track 2 indicators instead of 3. Now this actually also happens to be the minimum set of indicators in this case that can represent all these 8 issues. You can see how this, even in that simple case, you have a complex system, how much more difficult this selection process becomes when the number of issues and indicators rises. So to assist in this selection process and to help us find the minimum set of indicators that one may need, our team has developed a tool that identifies the smallest set of indicators required to provide information about a given set of issues. So this tool uses an algorithm that solves the well-known mathematical problem called the minimum covering set problem. So we have another webinar that describes this tool in a bit more detail, but basically it allows us to answer the question, what is the minimum set of indicators that can tell us something useful about the impact issues for groundnut sourcing in northern Nigeria? So the version of the tool that we use for this demo is an integer programming algorithm. The screenshot of the program is shown here. And this has the advantage of being very fast. It only takes about 5 seconds once you have the network set up to find the minimum covering set. So say we run this tool for the network of 14,089 indicators linked to those 15 impact issues that we selected for groundnuts in northern Nigeria. So the algorithm quickly identifies just 10 indicators here shown, and with the linkages between the indicators and issues shown here, that are able to represent all 15 integrated issues in their components. So this example shows the power of the tool, which is able to reduce the number of indicators by a couple orders of magnitude. So for users who have limited time and resources, this indicator set has quickly become very manageable. So just as in the example, once again, the lines here are showing the linkages. Still, this is nice, but even though the tool has succeeded in identifying a manageable set, this does not necessarily mean that this is the minimum set of indicators that we should use, or it doesn't mean that this is the list that makes sense for this case. So the tool has gotten us through another step to make the list more manageable, but now we can ask a more refined question to get at this manageable list. So instead, we can now ask, so what is the list of indicators that we should use for groundnut sourcing in northern Nigeria? And if we consider this question for each indicator in our minimum covering set, we may find actually that some of these indicators, although chosen by the tool, just really don't make sense for this case. So for instance, maybe a chosen indicator makes sense in Southeast Asia, but not in Africa, or maybe the indicator that's chosen is measured at a countrywide scale, but doesn't have any affordable data at the global scale in which it needs to be measured. So, or maybe an indicator just isn't a good fit for the framework in any specific context. So there are many reasons why an indicator might not be a good fit, but by asking this question, we can go through our initial minimum set and ask this question, and we can exclude indicators for these various reasons. For instance, extreme weather events and population growth, maybe better vulnerability metrics and then impact metrics, which we're concerned with in this case. And turnover profit may not be the best indicator to consider the impacts on global supply chain markets. So once we exclude these indicators from the pool of indicators, we can use our tool once again, and we just run it, and the tool chooses an updated set. So we run our tool, and within seconds we have a new list. So see here, you still have 10 indicators. The ones in bold are the same as from the first run. So the tool here chooses 5 new indicators to keep the indicator set as small as possible. But again, some of these new indicators might now not make sense. So for instance, the tool chose extreme climate events, which is very similar, and it's also a vulnerability indicator to extreme weather events, which we already excluded. So we exclude the ones that don't make sense, and we run it a third time, and within 5 seconds, we again have another list. And you can see this time, instead of 10, we have 11 indicators. So by knocking out indicators of contention, our algorithm can no longer find 10 indicators to represent all 15 issues, but instead it needs 11 to get the necessary representation. Now our team looked at this list right here after 3 rounds, and we already were very satisfied with the chosen indicators to represent the issues on the right, specific to groundnut sourcing in northern Nigeria. So within a very short amount of time, you can go from a list of over 2,000 indicators to just 11. Let's see here. So that's the main way that this process works, and that was one case where we went from a really large list of indicators to a manageable set, and one that could actually be used in this case. But consider a second case. So maybe we already know we have some partners who've been working in Nigeria on these issues for some time. Maybe there's specific farmers or commodity companies who are working there, and they're already using specific indicators, and they know that there's some specific indicators that should be used and should be on this list in northern Nigeria. So if we know that these indicators should be on there, we can actually lock in these indicators first and then run the model to complete the list. So in other words, we can use the algorithm to choose a manageable set to represent the main remaining issues. So to illustrate this for this demonstration, we've identified 4 indicators that we think should be on the list. The top 3 were identified in collaboration with our stakeholders as useful indicators with available data. And the 4th, greenhouse gas emissions, is quite clear and direct impact indicator. So if we lock in these indicators up front into the final set of indicators that must be there, and then we run our model to fill out the set, this case results in 13 indicators. So 9, in addition to the 4, you can see here we chose up front, linked to specific issues in their components, and the remaining ones fill out that list. So this step, only 2 more indicators are necessary than in case 1, and you can see that many of the same ones pop up again. So at this point, we could go through the same process we did with case 1, where we could eliminate indicators out of the 9 that the model chose that don't make sense, and we can repeat this process until we get a list we are satisfied with. But regardless, the point here is that the list is different than in case 1, and it highlights that this tool really doesn't necessarily provide the optimal or best list, but it's really an assistance tool so that users can get some help in choosing a manageable set. So both case 1 and case 2 looked at the impact of sustainable sourcing decisions, but users may just as well be concerned with the vulnerability of supply chains to specific issues. So therefore, for the next 2 cases, we'll take a step back and back to the issue list and consider those issues that make raw material sourcing more vulnerable. Specifically asking the question, is raw material sourcing significantly and directly exposed or sensitive to this issue? Exposure and sensitivity being ways to look at vulnerability. So now, just as in the impact framework, for the generic case, considering all commodities globally, our team at UC Davis identified 36 of the 44 issues as making supply chains more vulnerable. So almost all the issues here are relevant for the vulnerability framework. But also, in parallel with case 1, we want to be more specific and identify the subset of issues relevant for a specific commodity in a specific place. And then once we do that, then we'll find the indicator set for those specific issues, namely groundnuts in northern Nigeria. So once again, Tom and I took the new framework question for vulnerability and asked the question of all the 36 issues and their various components. So we said, well, is sourcing of groundnuts in northern Nigeria directly exposed and sensitive to this issue? With, again, exposure and sensitivity being 2 main criteria for defining vulnerability. And so we did this, and this step resulted in taking our list down from 36 to 24. So 24 integrated issues with just over 1,400 indicators to represent them. So if these are the issues that we must measure for vulnerability case 1, we must now choose the relevant metrics for this commodity and region. So once again, we go to our minimum covering set tool and use it to help us identify an initial indicator set. And within a few seconds, it provides us with the minimum set of indicators. In this case, once again, 13 are required to represent these 24 vulnerability issues, with the issues once again representing all 4 different capital groups here. But this really doesn't answer a question for us, as as we illustrated in the first few cases, because we would like to know what list we should use, not necessarily what the smallest set may be. So we refine our list by excluding indicators that don't make sense for one reason or another. For instance, we could argue that the effects of agriculture on climate change is good at measuring impacts, but not as good for measuring vulnerabilities in the supply chain. So again, we exclude this and a couple other indicators from the set, and we run our tool again, producing a new set. In this case, with only a few of the same indicators in the first run. So you can see that with those eliminated, it had to choose a completely different solution to keep our list low. Now once again, we eliminate indicators that don't fit, proceeding with this iterative process of eliminating indicators after each run of the algorithm, which, depending on the size of the issues and the participants in the process, could take many, many rounds. In this case, our team went through a third round, then a fourth round, and we went all the way through a seventh round of basically looking at the indicator list, excluding indicators, and rerunning our algorithm to help us fill out the list. Yet, luckily, these iterations rewarded us with a list of 14 indicators. Again, the ones in bold here are indicators that were selected in the first round that everybody in the room was comfortable with. So you can see that the bolded indicators are the ones that, again, appeared in the first run. So if we had just gone with the initial solution, we would have been still in pretty good shape. Although 14 is still small compared to 2,000, over a dozen indicators may still be way too many to measure. I mean, 14 is pretty good, but a group of users that simply wants to find a few metrics to start with to identify some key issues may not want to look at 14 indicators. So you can see that 14 indicators, quite different than the list that we came up for our first two cases. But if we want to start somewhere, we can actually do one more case, and so we specify vulnerability case 2, which came out of discussions with our Mars colleagues in the first phase of our sustainable sourcing project, in which we assume that representing only a portion of all the relevant issues is good enough. So here we say, well, let's make the portion of the issues that we want to cover 80%. And we want to see if that choice can help us focus on a few specific indicators. We start with a list of 14 that we derived, from which we derived vulnerability case 1, and we look at the network of issues and indicators. And we actually don't need to rerun the tool here, but we just need to use the network to find the smallest number of indicators needed to represent at least 80% of the issues. So by eliminating those with the fewest links, we find that actually only 6 are necessary to provide information about 80% of the issues and their components. So the second vulnerability case allows us to more than halve the list of issues and identify a few key indicators to start measuring and looking at and looking for data when considering the vulnerability of groundnut sourcing in northern Nigeria. And so this brings us back to where we started. So we've gone through 4 different examples here, 4 different cases, with each case showing how one can get from a list of over 2,000 indicators that cut across all these different issue groups to a manageable set that works for a specific context. So again, we're calling this our checklist generator approach. Leads us through the user through a process that gets us to a manageable set, giving the flexibility to define separate lists from the same pool of indicators, which provides flexibility while also maintaining consistency in the definition and credibility of the issues and indicators. So this point becomes particularly important to our team since our sustainable sourcing project in general promotes an open data philosophy with information about the issues and those indicators used to measure the issues, the frameworks, the sources, and ultimately the data associated with the indicators, alongside all the linkages between these information components. We believe that making that available to everyone. And also, since this project uses a controlled vocabulary to synthesize these definitions from various perspectives, which simultaneously link our information to other quote-unquote semantically enabled information and data sets. And so this point of open data is particularly important because users who go through this process then have the potential to share the results of this process, so their issue and indicator lists, with the global community and make their choices transparent and comparable with others. So our team is currently developing a wiki platform, a semantically enabled platform where this information can be shared and updated. So please stay tuned for an upcoming webinar which explains our informatics strategy and what the semantic web of information means and how it contributes to coming to a global, consistent definition of sustainable sourcing. So our team is also currently developing partnerships to use this checklist generator and to explore specific commodities and regions. So if you're interested in becoming a partner, please let us know. We're excited to begin generating checklists. So with that, thanks for listening, and stay tuned for more from the UC Davis Sustainable Sourcing Project.